in the class itself. Yeah, I will also sidely solve
Okay.
if you try. What? Write the question. Question is find the position of find the position of center of mass from point O, assuming density of solid cone is three times solid cone is three times the density of solid hemisphere. I will draw the diagram. This time diagram is little bit different. So before solving, make sure check all the things. Okay.
Okay, sir.
To draw the diagram, this is the solid cone. Okay. And this is the solid hemisphere.
Okay, sir.
Okay.
Okay, sir.
Now find the center of mass. Point 2 is here. This is point 2. Take x-axis here, y here. Okay.
Okay, sir.
And height of cone is 8r and radius of hemisphere is r. Okay.
Okay,
Solve.
sir.
Try this. First of all, find the coordinate and tell me. Check the notes and tell me where is the center of mass of solid hemisphere.
Okay, sir.
Tell me.
So 3R/8.
Okay, from the center of solid hemisphere, it is 3r/8. So here is the from this. But where is my coordinate axis? Here. From here, how far? It will be 0, comma 8r plus 3r/8. Okay, clear? Because we are taking reference here. From here, it is 3r/8. This much. Okay.
Okay. Okay, sir.
But from the point 2, because they are asking from point 2. Similarly, from the base, this is the base of the solid cone. From here, center of mass will be h/4. It will be here. Its center of mass, it will be 0, comma h/4 means at 4r from the base. From the base, it is
Okay, sir.
4r. Okay. For not 4r, it is h/4 means 4 to the 8, 2r. Okay. But from the
Okay,
origin,
sir.
it will be 0, comma 6r. You got the coordinate?
1 minute, sir.
Hmm. And they have mentioned like density of solid cone. Density of cone is 3 times the density of hemisphere. The density of hemisphere is 1/3 the density of solid cone. So if I ask what is the mass of cone, volume into density of cone multiply volume, 1 by 3 pi r square h. H is how much? 8r. Okay. And if I ask what is the density of hemisphere, Density of hemisphere, that is 1/3 of the density of cone.
Sphere.
Clear?
Mm.
Multiply
Yes,
volume.
sir.
Volume of a hemisphere is 2/3. You know this, 2 by 3 pi r cube. Okay.
Okay, sir.
So what if you find the relation? If you take MC, if the MC value, that is rho c, multiply 1 by 3 pi multiply 8 r cube. If I take this value m, small m, okay, then what is the
Okay,
value
sir.
of mh? Mh will be, it is 2 common, 2 pi, 2 by 3 pi common, multiply, it will be what? 1 by 3 pi r cube multiply what? If I take 2 by 3 pi outside, inside will be 1 by 3 pi r cube rho c. Okay.
Okay, sir.
But if you check the small m equal to 1 by 3 pi 8 r cube into rho c, there is no 8 here. So you will divide and multiply. There is no pi here, first of all, because we take 2 by 3 pi common. So it is 1/3 1 by 3 rho c r cube. Okay.
Okay, sir.
There is no 8 here, so I will divide and multiply by 8. Okay. So it will be,
Okay, sir.
mass of hemisphere will be 2 by 8 3 is 24 pi, and this become 1 by 3 rho c, rho c, and I think pi also will be here. Okay.
Okay,
You
sir.
check carefully. 1 by 3 rho c 8 r cube.
Sir,
Okay.
1 by 12 m.
So 1 by 12. Check all the calculation. Check all the
Yes.
calculation. Is it okay?
Okay, sir.
So mass of cone is m, then mass of hemisphere is what? 1 by 12 of m. Check all the calculation. Is
M.
it okay? Because calculation
Okay,
mistake,
sir.
if I make any mistake in calculation, then answer will be wrong. Clear?
Correct,
That
sir.
is, our job is to make you understand how to apply, how to approach a question. Okay. Now you got
Okay,
mass
sir.
of cone is m. You got a coordinate. Its coordinate. Its coordinate is 0, comma 6r. And what is the coordinate of this cone? 0, comma hemisphere. Sorry, 3r plus 8r plus 3r. That is 8 8 is 64. 64 plus 3, 67r by 8. Okay.
Sir, can you please repeat, sir?
What is this? 8r plus 3r by 8. It is what? 64 plus 3r na 70 67r by 8.
Yes, sir.
Clear? So 0, comma, what I should write? 1 minute. 67 r by 8. Clear? This is for hemisphere. Okay.
Okay, sir.
This is for cone. Now they are as a discrete system. If they are a discrete system, it is confirmed center of mass will be where? It will be lie here only on the y-axis, somewhere here. These are two particle
Yes,
system
sir.
now. Now this is two particle system. And how to find the center of mass of two particle system? It is very easy. X1, Y1, X2, Y2. Mass of hemisphere is 1 by 3, 1 by 12 of mass of cone. Here mass of cone is what? Small m. You can check. Okay.
Okay, sir.
So apply the formula. YCM will be what? XCM is 0. YCM will be M1 X1 plus M2 X2 divided by M1 plus M2. Okay.
Okay, sir.
So M1 is how much? Mass of, you can take M1. This is M1. This is M2. Okay.
Okay, sir.
So M1 is mass of cone is M. It's Y. YCM na, so we will write Y1, M1 Y1, M2 Y2. Y1 is 6R plus its mass of its hemisphere is 1 by 12, like this. Its Y2 coordinate is 67R by 8. Okay,
Okay, sir.
divided by total mass, M plus 1 by 12
13 by
M.
12 M.
So you just solve how much total YCM will
Sir,
become
13
Y.
by.
No, total how much? Just solve this. What is the answer? If you solve, you will get 643.
Sir, sir, Y1 will be 67R by 820 now, sir.
Ha. No, no, no. I have taken this M1, so it will be X1, comma Y1. If I take M2, this is X2, comma Y2. Okay.
Okay, sir.
So this is the answer you are getting. Just check. YCM.
Sir, I done a mistake, sir, on this.
No problem. So coordinate will be, it will be 0, comma YCM. That is 643 R by 104. You just check.
1 minute, sir. Sir, it came, sir.
Okay. Now write one more question. This is a little bit tough, but I think I will make it up for I think easy. You can solve or not. Let me check. Uh,
Okay, sir.
you try this question. If you have any doubt, you just ask me. Okay.
Okay, sir.
Write down a solid cone. I will increase the test size. Write down a solid cone is removed from solid hemisphere. 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 Okay. Find the
Okay, sir.
center of mass of remaining part from C. Where is C? I will explain. Okay. Now here we are removing. Okay. So we will subtract. We will not use M1 X1 plus M2 X2. Okay. We will remove the portion which we are going to subtract now, which we are going to remove. We will do the subtraction part. Okay. We will do M1 X1 minus M2 X2. How to do? I will tell you. Okay. Let's draw the diagram.
Okay, sir.
Meaning is what? A solid cone. First, this is our solid hemisphere. This is our solid hemisphere. Okay.
Okay, sir.
From this solid hemisphere, this is center. From this solid hemisphere, I will draw again. Where is the center of mass of solid hemisphere? From the
Sir,
center,
3R by 8. 0,
3r by
3R
8.
by 8.
0, 3r by 8.
8.
Radius is r. Again, I will draw this solid hemisphere and I will tell this is solid hemisphere. Okay. Center is
Okay,
here.
sir.
From this solid hemisphere, we just cut a cone. A cone is cut. A solid cone is removed. So how they are removing? They have mentioned a figure like this. They cut the portion like this. Okay. This portion they have cut. A solid cone they have cut. Okay. For this solid cone, radius is still r. What is the height of cone? R. Okay. This is concept. Okay. This cone, when you remove this cone, finally you are getting what? You are getting like this Shape will be like this. Like this. Okay. This is the
Sir,
shape.
can you please, sir, can you repeat it, sir? Network issue.
See, this is the solid hemisphere. From this solid hemisphere, solid cone is removed. Means we cut.
Oh,
This
okay,
portion,
sir.
green portion which I have drawn, we have cut. So it shape will be like this, na?
Yes, sir.
Which portion we have cut, I will draw here sidely. I cut a cone. This is a cone. Okay.
Okay, sir.
Now, if you look
Sir,
at
the cone is
carefully,
symmetrical or not, sir?
symmetrical cone we have cut.
Okay, sir.
Height of cone is r. Okay. So its center of mass will
Okay.
be c from the from the base. It is how much? It will
H by
be
4.
h by 4 means 0 comma r by 4. Clear?
Okay, sir.
Now, if I ask you, this cone is a part of solid hemisphere earlier. If you look at carefully, the mass of solid sphere will lie here, and it will lie here, and it will lie in this cone. Clear? So, if you
Okay, sir.
combine, if you take this cone and put it in this cavity, then again its center of mass will be 0, comma 3r by 8. Clear? Its center of mass will be 0, comma 3r by 8
Yes, sir.
again. But if you cut, then there is a shift in the center of mass. Center of mass will not be there. Okay? Is it okay for you?
Okay, sir.
Center of mass will not
Sir,
be here.
please
So
repeat
what
it
we will
again, sir.
do, what we will do, we will subtract from the center of mass of this solid hemisphere, we will subtract this portion center of mass. We will do like that. My question is, where is the center of mass of this cavitated portion? Where is center of mass of this? This is y, this is x. Now, where is center of mass? You know, in this portion, mass will be here only. There is no mass in the middle.
Yes, sir.
Mass will be here. So now center of mass will not be for this shape. They are asking where is the center of mass. They are asking the center of mass coordinate. It will be 0, comma ycm, but we don't know where is the ycm. That is the question. Clear? If it is complete
Okay, sir.
solid hemisphere, then it will be what? Coordinate will be 0, comma 3 ry. But we cut a portion. We cut a portion from this cone, from this solid hemisphere. We cut a portion this much. And finally, we are getting this shape. I want to know where is the center of mass of this. Clear? So it is confirmed. Now, center of mass of this remaining portion of solid hemisphere will not be at 0, comma 3r by 8. It will be little bit drop because we decrease the mass. Okay. Center of mass means it is a point where entire mass is supposed to be concentrated. Now, the mass we already reduced. Clear? Now, we need to find where will be the center of mass. Now, you please tell me, first of all, you are cutting. What you will do here, initially solid hemisphere is this. Okay. You cut a portion. This portion you have cut.
Sir, one minute, sir.
Clear? This is M1. This is R. And this is what? This is M2. So M1 is how much? Density of sphere multiply its volume 2 by 3 pi r cube. Similarly, M2 will be what? This is R. Density multiply 1 by 3 pi r square into h. So it will be what? If this is m, this is 2m. Okay. So m1 is the mass of solid hemisphere before it is cut. Okay. m2 is the cut part, solid cone. Okay. Is it okay?
Okay, sir.
So you know the center of mass of this 0, 3 r by 8. You are right. Now center of mass of this will be h by 4, means 0, r by 4. You will say like this. Clear? Okay.
Yes, sir.
M1 is what? Mass is equal to volume into density. So density multiply volume. Volume of solid sphere is 2 by 3 pi r cube. Similarly, for M2, mass of solid cone, that is cut portion. That is cut. Okay.
Okay, sir.
Now I need to find the axiom. Not axiom. I think it is YCM. Axiom is 0. So YCM is actually what? Center of mass axiom YCM, which we have written. Actually, it is a weighted average. It is the average of weight. It is average of weight. You please tell me now. Some weight has been reduced. Some mass has been reduced. Okay. It is average of what? Mass. Sum of all the observation divided by total number of observation. Now, initially,
Yes.
total observation is how much? You will write like this: total mass m2 m1 x1. Clear? m1 x1.
Yes,
Now
sir.
some observation has been reduced. Some weight has, some mass has been reduced. Okay. So we will do subtraction of this m2. Okay. Same formula
Okay,
m1
sir.
x1 my m1 y1 minus m2 y2 हो जाएगा is direct. Okay, m1 y1 minus m2 y2, because what is a YCM? YCM is weighted average by total number of observation. Now we have cut that portion. That's why we will use m1 y1 minus m2 y2. Clear?
Sir, yes, sir.
So same thing I have applied. This is one body, second body. But in place of plus, I will write minus because mass has been reduced. This x1 y1, it is x2 y2. Okay.
Okay, sir.
So
Okay,
many
sir.
questions like they have asked in IITs, such type of question like. So once you solve, you can take m com, because down m will come, m common. So it will be 3r by 4 minus r by 4. So once you solve, you will get r by 2. So coordinate will be what? For this cut portion, this is now. For this shape, its center of mass from C will be where? At 0,
R, sir.
r by 2. Is it clear to you?
Yes, sir.
You try one question, okay? I will give you one more question, same type. Mass is here. For this, mass will be here. You try one more question. Just question you should try. I will show you. Have you written this?
Sir, yes, sir.
Okay. Right, next question. Same question I will ask you. You try this question. Same way you should write. 1 minute. I will share my screen again. This question I asked in IIT actually. Next question also I asked in IIT.
Okay, sir.
Right now. Chapter is finished. Only numerical portion is left.
Okay, sir.
Write down a disk of radius r by 2, r by 2, 2 capital. Okay. Okay, it is coming like this. Is removed from a bigger disk, from a bigger disk of radius r, as shown in diagram. I will draw
Okay.
diagram. Find the position of center of mass from C. Now, what is C? I will explain. Okay.
Okay, sir.
Now, draw this figure. We are having the disk. Clear? This is the disk.
Okay, sir.
This disk symmetric body center of mass will be here, and this is R. We cut a section like how they are cutting. Again, I will draw the disk. Clear? Center is here. This is R. So how they are cutting? What they are saying? They are saying from a bigger disk of radius R. From bigger disk of radius R, a radius disk of radius R by 2 is removed. Clear? So see, this is
Sir, then
R.
the
R, this is R. So R by 2 will be here only. Like this. They cut this much portion. Okay.
okay, sir.
This is R na, R by 2. Like this portion they have cut. Now what is the shape?
Sir, crescent moon like
Something like
crescent
here.
moon. Sir.
Crescent moon. Yeah, very good. It will be some empty space. Here nothing is there. Mass will be here. Here will be the mass. Now where is the center of mass? Question is that. So same thing like apply where is center. First of all, I will explain where is center. Center C is here. Okay. It's from C. Here draw X or Y. X, Y. Okay.
Okay, sir.
Now you place what is the coordinate of this 0, 0. And the portion which you have cut, you can draw here. Which portion you have cut? This is the portion. If this is R by 2, okay, its coordinate will
Okay,
be
sir.
what? R by 2 comma 0. Its center of mass will be here na. C2, its coordinate will
Yes, sir.
be R by 2 comma 0. Here na. This is C from C. X or Y. X, Y. So its coordinate of the cutted portion will be here na. Center of mass will be here. It will be R by 2 comma 0. Okay. Get it
Okay,
out.
sir.
Now same pattern. What is the mass of this? Find this mass. Mass of disk. Disk will be what? Volume,
Sir.
density. Let us suppose rho is the density. Density of disk, rho, multiply volume of disk. Volume will be area into thickness. Clear? Area of disk will be pi r square. Thickness you can take small t. Okay.
Okay.
Similarly, for
Okay.
this cutted portion mass, it will be because same from the same bigger disk we are cutting this portion, so density of this will be remain same. Clear? Its pi
Okay,
radius will
sir.
be r by 2. Okay. Multiply
Okay,
thickness.
sir.
So you please tell what is the relation between these. If M2, if I take M2 will be M, then what is M1? It is pi, what is this? Rho pi r square multiply t by 4. Okay. So divide and
Okay, sir.
multiply by 4. So it is 4 times of M. Is it okay?
Okay, sir.
Now apply the formula. YCM. YCM will be M1 Y1. This M1 X1 Y1. Okay. So what is the mass?
Okay.
4M into Y1 is 0 minus because we cut. Okay. What is the answer? F y2 is how much? R by 2 total mass. So mass reduced now 4m minus we will write sum of all observation divided by total number of observation. So YCM will be what? So actually it is not
1
YCM, it is
1
XCM. YCM is 0. Okay. XCM. Sorry. It will be how much? Minus R by 3 or what? 6, I think. Okay.
1
Minus R by 2 by 3m. So coordinate will be minus R by 6, comma 0.
Yes,
Okay.
yes, sir.
So for this
Okay, sir.
portion, for this crescent moon which you are telling now, this is crescent R by 6. Minus R by 6 means what? This is center. Okay. From the center,
Okay, sir.
its center will be R by 6 behind. Here will be minus R by 6, comma 0. Meaning is that x plus x plus y. Okay.
Okay, sir.
Now, did you notice like the portion because of cutting small portion R by 2? How much shift in the center of mass? Earlier it is 0, comma 0. If somebody is asking what is the shift in center of mass, delta x cm, it will be what? Final, how much? Final it is final minus x2 minus
Sir, one
x1.
second. Final.
Now final it is at where? Minus r by 6 minus initially 0. So how much shift? Minus r by 6. You know, understand shift in center of mass? This is shift
Yes,
in
sir.
center of
But
mass.
okay,
Delta
sir.
x cm, which I have told. Shift in center of mass. So by cutting a small r by 2, simple or small r by 2, how much shift? Minus r by 6. If you take this portion, if you take this portion, you know, if you take
Okay.
the portion which you have cut, for example, this is the shape now. Okay. The portion which you have cut,
Okay,
if
sir.
you join these two, you will get a solid hemisphere. Okay. Earlier
Okay,
center
sir.
of mass will be here like minus r by 6, comma 0. Okay. Now again it come back to the center because you added the portion which you have cut. There will be symmetry again. Now if you ask now what is the shift in center of mass from here to here? What is the shift in center of mass? Delta xcm final minus initial.
Sir.
Now how much shift?
Okay, sir.
Final it is at
Delta.
0. Initially minus r by 6. So how much shift? R by 6. R by 6 positive means R by 6 positive means it moves R by 6 in the right. Plus R by 6 means it is earlier it is R by 6 back. Now after putting this portion here, the center of mass again reaches here. Meaning is that it moves R by 6.
Okay,
Shift
sir.
of R by 6. Plus R by 6 means in the right. It moves in the right. Minus R by 6, it moves in the left. Minus means that. Okay.
Okay, sir.
This is in detail I have explained. Any doubt?
No, no doubt, sir.
Okay. Okay. Next question, write down. I think this question I should explain or not. Hmm. Some question we will learn from. This question. This is a very good question. Question is, write down the question. Hmm. Write down the question. This type of question also you should solve.
Okay, sir.
Write down. A port Write down the question. What will be the question? Write down.
Okay.
What will be the displacement of boat when Ramesh comes to another corner? Options are given. 1 minute. 2.2 meter back. 2.2 meter back. Option B. 2.2 meter forward. C. 2.4 meter back. 2.4 meter back. 2.4 meter forward. Okay, I will draw the diagram. You try this question, very good question.
Okay, sir.
And I think you can solve if it's right. It is, if you can solve, no worry. Otherwise, it is board actually. I have read board. It is board. Okay. So what will be the
Okay.
displacement of board when Ramesh comes to other corner? So I will draw the figure. This is the boat, and this boat is in the river. Okay. And here one person is standing. This is Ramesh. Okay.
Okay, sir.
The length of this boat is, this is 4 meters. Total 4 meters. And this boat is in the water.
Okay, sir.
Person is standing on the boat. Okay. This is, he's on the boat. He's moving on the boat from one corner to another corner. Okay.
Okay, sir. Okay, sir.
This is first corner, second corner. Question is, if he moves, listen one more thing, like initially person is at rest. If a person is initially at rest, then what is the meaning of that? System. Here system
Sir?
is, system here, system is person in the block, boat. Okay.
Okay, sir.
I have taken this is my system. Initially, everything is at rest. Clear? He is standing here. Boat is also standing. It is not moving. Once a person start, then it is moving back. You just tell me if a person is moving in the forward direction, then boat is going in the backward direction.
Yes, sir.
Yeah. And initially he is at rest. He is at rest. So, but this is, you can take M1. This is M2 boat. Okay. Now,
Okay, sir.
interesting thing is here, there is no net force. There is no net force. Externally, one looking, there is no net force. Okay, on the system. If there is no net force, then acceleration of center of mass will be what? 0. Okay,
Yes, sir.
well, you have learned now this ACO, center of mass is net force divided by total mass. So if it is 0, then ACM is 0. And if ACM is 0, then velocity of center of mass is, there is no change in the velocity. Clear?
Okay, sir.
VCOM is constant. And it is equal to what? There is no change means it is equal to initial. Initial is what? You please tell me. Initially, everything is at rest. Initially what? Net force is, you please tell me. Initially or everything is at rest.
Yes,
Clear?
sir.
Then there is no net force acting on this. Initially at rest, it means the change in velocity finally is also at rest. So VCOM is 0.
Okay.
Okay. There is no change. If initially he is moving now, if initially center of mass and some velocity, then finally it is also having the same velocity. Clear?
Okay, sir.
Initially at rest, net force is 0, ACM is 0, then velocity of center of mass is constant, and this constant is equal to 0. Because initially the center of mass is at rest, then finally it is also at rest. Then if center of mass is at rest, you please tell me, if initially it is at rest, finally it is at rest, then do you see any shift in center of mass? Is there any change in center of mass?
No, sir.
Same will be 0. It means what? M1 displacement mean delta x1 plus M2 delta x2. It will be 0. Okay. What is this? Delta x1, delta x2 means what? Displacement of
The board.
M1. This is for boat.
Okay,
Clear?
sir.
Now boat is on the, where is the boat? Boat is on the ground.
Reverse.
Ground means river is on the ground means boat, the, if boat is moving x distance back, the displacement of boat is x meter for
Minus.
backward. You please tell me. We want our VCUM is 0. VCUM 0 only possible when a person is moving in the forward direction, boat is going in the backward direction. Then only VCUM is 0. Clear? Because VCUM formula is what? If you look at carefully, VCUM 0 means what? M1 V1 plus M2 V2 divided by M1 plus M2. So V1 V2 must be opposite. Then only it will be 0. Otherwise, if they are in the same
Okay.
direction, M1 V1 plus M2 V2 will add it. Clear? So
Okay.
these both should be, if a person is moving in the forward direction, now, if he is going from one corner to another corner, then boat is going in the backward direction. Boat is going in the backward direction. Is it okay?
Okay,
Let us
sir.
suppose boat is going displacement of boat from the initial condition is how much? It is going 1 minute. It is going x meter back like this. It is going x back. Clear?
Yes, sir.
So this boat is on the ground actually. It is still condition means it is not moving. But when a person is moving, then suddenly it is moving. Clear?
Okay, sir.
Then you please tell me displacement of boat with respect to ground will be minus x. It is going back. Okay.
Okay, sir.
While the displacement, the person is moving, then if person is moving what? If you are the observer, you are standing here. Then with respect to boat, person is moving on the boat now. Then he will travel 4 meter on the boat. But with respect to the ground, if a person is on the ground, did he travel 4 meter? No. Okay. With respect to the
Okay,
boat,
sir.
if you are on the, he is traveling 4 meter, but boat is also coming back now. Boat is going back and he is traveling forward direction. Then with respect to the ground, distance will be little bit less.
Okay,
Okay.
sir.
Is it clear?
Okay, sir.
So in this
Yes,
formula,
sir.
na, if you are writing delta x2 with respect to ground, then delta x1 also with respect to ground. So displacement of this man or a Ramesh with respect to boat, it is 4 meter. Okay. But if you write
Okay, sir.
displacement of Ramesh with respect to ground, it will be what? Can we write like this? You know this concept? I will revise. Okay.
Sir,
This also, I think you forget like velocity of man with respect to trolley, Vm minus Vt. So you can take
third law of motion.
this is relative velocity concept. You know this?
Sir, you can also solve by third law of motion, no, sir?
Third law of motion. Like for every action, there is equal and opposite reaction. If he is going in the forward
Ah, yes, sir.
direction, reaction will be back.
Oh, okay, sir.
So displacement of Ramesh with respect to boat can be, we can write like this: SR minus SB. We can take ground here. Like this, I explain this concept, relative velocity concept. Okay. Then
Okay,
we
sir.
need to write displacement of Ramesh with respect to ground because we are writing with respect to ground. Displacement of boat with respect to ground is minus x because boat is on the ground. Clear?
Okay, sir.
So it will be 4 meter. Clear? Because river is also on the ground, so we can say the displacement of river with respect to ground will be 4 minus x. Okay.
Okay, sir.
Now put the value mass of the person. How much? This person is having the mass. You can write this is 60 kg. Okay. And this is 4m. I have written 4m or what? 4 meter. Mass of m2 what will be? You can write 40 kg. Okay.
Okay, sir.
So this is the concept like here. If you should apply. So m1 is how much? 60 kg. Delta x1 is the displacement of person on the, not on the, where? Person displacement of Ramesh with respect to ground. How much? 4 minus x. Okay. Plus
Okay,
m2
sir.
for boat 40 kg. How much it displays? Minus x back. So if you solve what is x, tell me. X
7,
will
sir.
be how much?
Sir, 1 minute, sir.
Hmm. X will be
240. Sir, 240 by 46.
2.4. 2.4 meter plus 2 point plus means what? Plus means what? Plus
Sir,
x.
the boat is moving in the
Left
right.
direction. Person is moving in the,
Right.
okay, what way? Boat. Clear? Minus x. Minus x. X. Already I have taken sign. Did I take sign here? Okay. So in the answer you
Okay,
will get
sir.
magnitude only. Plus 2.4. Clear? So your answer is 2.4
Oh,
meter back. If you take sign already, then sign will not come again. Okay. The quantity which you are going to solve, if you take sign already, the sign will not come again. Is it okay?
oh, okay.
Now next question is write down. Write down the question. 1 minute. Next question, write down. Write down. By what distance? By what distance the balloon shifts downwards when monkey reaches topmost point? Okay. Option A you can write m capital L by m plus m. Option B 2ml small. Okay. It is capital M here. What is capital M? I will explain. Okay. 2 small m L divided by m plus m. Option C small m, it is capital L divided by m plus m. Okay. Option D 2ml by m plus. This is also same pattern, same concept we will apply here also. The previous question which we have applied, same thing we will apply here. Now question is little bit not complicated. Question is like that. By what distance the balloon shift downward? Okay, this is a balloon. Okay, and this is the length of the balloon string. And on this balloon, the length of the string of the balloon is L. Okay, and monkey is where? The monkey is here. Okay, Monkey is here. Monkey is okay. This is a monkey. Okay, this is a monkey. My question is, by what distance the balloon shift downward? How much balloon shift downward when monkey reaches topmost point? When monkey reaches topmost, this is the topmost point. The height of the balloon is negligible as compared to the length of this string. So we will neglect. Topmost means monkey, when monkey will reach here at the top. Mass of the balloon is capital M. Mass of the monkey is small m. Okay. Now, if you look at carefully this question, can you solve this? Hello.
Sir, I'll try to solve.
Initially, system is at rest. Okay, nothing is given. The system is what? This is our system.
Rest.
Monkey and balloon. Monkey
Okay,
as
sir.
balloon. Initially, both are at rest. So net force is 0, ACM is 0. Okay, there is no external force on this. Internal force will be there. I'm not talking about that. Okay. Internal acceleration will
Okay,
be
sir.
there. But our objective is to tell you like ACM will be 0 because net force is 0. Clear? Internal force will be
Okay,
there,
sir.
but it will be in opposite direction. For every action, there is equal and opposite reaction. If monkey is doing like this, he is doing action. Reaction is he is going up. Okay. Initially system.
Okay,
Do you
sir.
see like initially system is at rest. Initially when monkey is not going up, he is not doing any action. Initially both are at rest. Balloon and
Sir,
monkey.
sir, when monkey is trying to pull the balloon to move up, the balloon will come down now, sir.
Balloon will come. Very good. So let us suppose balloon will come down by x. Okay.
Okay, sir.
Balloon come down by x. Now, what is the displacement of since monkey is going on this? You please tell me if you are looking from the ground. If you are the observer on the ground, according to you,
Okay, sir.
displacement. What is the displacement of monkey with respect to ground? It is not L because balloon is also coming down.
Yes,
Displacement
sir.
will not be L. Clear?
Okay, sir.
He will catch the balloon before. He will not take L distance. Okay? He will reach the topmost
Okay, sir.
point before covering L. So L, it will not be L because balloon is also coming down. So balloon, clear? Tell me what is the answer? Initially, system is at rest means do you see any shift in center of mass? Initially, center of mass at rest. So velocity of center of mass initially at rest, then finally also it will be 0. Clear? So if it is
Okay,
0,
sir.
velocity is dx delta x by delta xcm by delta t or dxcm by delta t. So delta xcm means there is no shift in center of mass. So m1 delta x1 we can write. So they will move in such a way if balloon is going up, then balloon is going down, monkey should go up. Then only this m1 delta x1 plus m2 delta x2 will be 0. One should be
Okay,
positive,
sir.
one should be negative. Then only sum will be 0. Na?
Yes, sir.
Now displacement of balloon with respect to
Balloon will
ground.
be
If you look
negative.
at it is minus x.
Yes, sir.
Okay. Displacement
Okay, sir.
of this monkey with respect to ground. Displacement of monkey with
Positive.
respect to balloon. Sm G minus SBG. Can we write like this?
Yes,
Displacement
sir.
of monkey with respect to balloon means if you are the observer, if you are standing on the balloon, with respect to balloon means what? If you are the observer, if you are standing on the balloon, then according to you, balloon is not moving, then monkey will travel this much distance, L, it will plus
Okay,
L.
sir.
If you are standing in the car and car is moving, then if you are not looking outside, then car is at rest. You are seeing car is at rest. Okay. Displacement of monkey with respect to ground. Displacement of balloon, how much it displaces minus x. So what is the displacement of monkey with respect to ground? L minus x. Okay. So M1, you can take this is M1. Okay. This is
Okay,
M2.
sir.
So put the value M. How much it displays? L minus X plus balloon minus X. What is the value of X? Tell me.
1 inch, sir.
Hmm.
Sir, the value of L is
X.
2x. X is L by 2.
X will be ML minus MLX plus M into minus X. So X will be what? Small m into capital L divided by small m plus capital M. This is the answer. Okay. It is small m.
Sir,
Check again. One, both options are same now, so we can take this small m. Option C correct. Okay.
okay, sir. Okay, sir.
Now one more question like write down. Last question I think. Write down. Write down
Sir,
the
can I
question.
do this question as homework?
Homework I will. This is the last question for your homework. Write down. Find the see external force in this question will be zero in one direction. It may be in X, it may be Y. You should think, okay? That is only condition I
Okay,
can
sir.
tell. Write down. Find the distance moved by wedge. Wedge, you understand? Inclined plane. Mass is 10 m. 10 times of person. When the block mass capital M, okay,
Okay, sir.
reaches lowermost point. Lowermost point. Okay. I will
Okay,
draw
sir.
the figure. Questions are many, but no worry. It's timely. You should be familiar. Okay. Options are here. Write on the option. Point one. Option B. Point two. Option C. Point 0.01. Option D. Point 0.02. So this is a wedge. On this wedge, this is wedge. Okay.
Okay, sir.
Inclined plane. We are saying wedge. 90 degree. Question is when the block. And one more thing. This wedge is placed on a frictionless surface. Otherwise, you will say some friction is there, external force, frictionless
Okay.
surface. Okay.
Okay, sir.
If a block is placed on this, if a block is placed like this, okay, this
Okay,
block
sir.
is moving on this. Yeah, it is having mass capital M. The mass of this is 10 capital M, 10 times. And this is 2 meter. Okay.
Okay, sir.
One thing, if this block is going down, then wedge will be
So
going back.
the hypotenuse is 2 meter or height is 2 meters, sir.
1 minute, actually, my laptop is going to discharge. I will charge. Yes. Yes, what? Hypotenuse,
Sir,
nothing is
the
given.
hypotenuse.
Nothing is given hypotenuse that no need actually. That is a question only. They have
Okay.
given only this 2 meter from here to here. This is wedge.
Then what is the 10 meter, sir? Okay, sir.
Nothing is given. That is the question. Na?
Okay, sir.
If this is moving like this, okay. You please tell me if this block is going down, then it is confirmed there is shift. It should move back. Let us suppose X. Okay. If
Okay, sir.
anything like on wedge it is going down, then there is some displacement in the wedge itself. Clear?
Okay, sir.
Now, very clear like V sum is constant. Clear? Now you need to think
Okay.
in which direction net force is zero. Okay.
Okay, sir.
Solve this at your home. Answer is 0.2. Answer is 0.2. This is the question. Okay.
Okay, sir.
I have one more question. Can I ask?
Yes, sir.
I will give for homework only. This is first homework. One more question for homework. Otherwise, this will miss. Question is, hmm, like, okay, right. Ramesh, actually it is font is a bit slow.
Okay, sir.
Ramesh and Mahesh moves to the center of boat. Find the displacement. Find the displacement of boat if initially system was at rest. Okay.
Okay, sir.
Option I'm giving. This question is same as previous question. 11 centimeter forward, but here two-person are moving. Okay. 11 centimeter
Okay, sir.
backward. Option C. 13 centimeter forward. Option D. 13 centimeter backward. Okay.
Okay, sir.
I will draw the figure also. Draw the figure. This is the boat. Around this boat, there are two person. One person is here. You can take his Ramesh. Okay. And
Okay,
one
sir.
person is here. He is Mahesh. His mass is 50 kg. His mass is 60 kg. Okay.
Okay, sir.
And the boat mass is 40 kg. And this is 4 meter. Okay.
Okay, sir.
4 meter length of boat. So they are asking already they have mentioned initially system as at rest. System you can take this boat, Mahesh, Ramesh as system. Okay. Boat is in the
Okay,
water.
sir.
Okay.
Okay, sir.
So same thing like you can it is going in the they should move up to the what they are saying. Ramesh and Mahesh moves to the center of boat. Center of the boat is here. 2 meter. He is moving 2 meter with respect to boat. He is also moving 2 meter with respect to boat. Okay. Clear?
Okay, sir.
Then simple
Yes,
question
sir.
like whether he is moving in the right, he is moving in this direction. We just consider, let us suppose by the displacement of these two person, boat shifted where? X back, X meter back. We don't know what is that. Okay. So apply this
Okay, sir.
simple. Now this time M1 delta X1 plus M2 delta X2 plus M3 delta X3 to 0. Put all the displacement with respect to ground. Okay.
Okay, sir.
If they see one thing I want to explain, this portions today's session over. I want to explain like if anything is moving on a certain object, for example, if you are standing on the boat and you are moving on the boat, then
Okay.
your velocity with respect to boat only. If you are moving on the ground,
Okay.
your velocity will be on the with respect to ground. Clear? If you are in the
Okay.
lift, then your velocity with respect to lift is zero, but there is different velocity with respect to ground. Okay. But if
Okay,
I
sir.
write, if you are
Okay.
in the lift, if you are in the lift, clear, then whatever is the acceleration of lift, you have the same acceleration if you're looking from the ground. So if a person is moving on the boat, if we are saying the person is moving 4 meter per second on the boat in the right, it means this velocity
Okay.
with respect to the boat itself. Okay, because both are moving.
Okay,
If I am saying like he is moving 4 meter on the boat, if boat is at rest, if boat is not a what like boat, if boat is at rest, then it is confirmed he is moving 4 meter with respect to ground also. Okay, but here is what
okay,
is the
sir.
problem here? Boat itself is moving. So he is not moving 4 meter, he is moving little bit less. That is 4 minus x. Okay,
Okay, sir.
clear? If you are looking from the ground, that's why we are writing 4 minus x. So if you are writing delta x1 with respect to ground, delta x2 must be from the ground. Clear?
Okay, sir.
Okay, thanks a lot for such a long session we have, and we learn a lot of things.
Yes.
And we have various question. If you solve center of mass questions, a very interesting topic, and many questions asked in
Okay.
IIT JEE from this topic. And now onwards, we will start. We have finished many chapters. Now we will start rotational motion. Clear? In the next lecture, I will
Okay.
start
Okay.
rotational motion. Rotational motion, it is system of particle and rotation. System of particle we have finished. Now rotational motion we will learn. We will learn angular momentum, rolling motion, pure rolling, everything we will learn. Okay. Then after that,
Okay, sir.
oscillation. Oscillation wave, two chapters were there. Then thermodynamics. Then like Hooke's law, that is different thing. So second book we will start after this. After this, okay.
Okay, sir.
Okay, Dinesh, take care. Bye bye.
Bye, sir. Thank you, sir.